Hi everyone, and this lecture topic is mechanism of stabilization. As you all know, we have seen what is stabilization. Now let us see about the mechanism. First, we have to know what is stabilization. It refers to the process by which unstable or hazardous substances within the waste are transformed in treated to render them less harmful, or they are made inert or inactive, and in this process this reduces the potential of the substances to pose risk to human health or to the environment. And here we have the various what is called the mechanisms like chemical transformation, biological transformation, physical transformation, ion exchange, adsorption, etc. Let us see into them one by one. First one is the chemical transformation. It involves altering the chemical properties of hazardous substances through reactions that convert them into less toxic or more stable forms. This includes processes such as oxidation, reduction, hydrolysis, precipitation, and complexation. For example, heavy metals may be chemically stabilized by converting them into insoluble forms that are less likely to leach into the environment. And next one is the physical encapsulation. We all know that we have seen the previous video about what is encapsulation. So it is the capturing the hazardous substances, and we are making it immobilized, and we are then maybe safeguarding, or we are disposing. So here it stands for the physical and stabilization involves encapsulating or immobilizing hazardous substances within a solid matrix to prevent their released in the environment, and this can be done by encapsulation in cementitious materials, polymeric matrices, or inert barriers. Physical encapsulation physically isolates the hazardous substances, preventing them from interacting with the surrounding environment. And next one is the biological transformation. This is by using the microorganisms or enzymes to degrade or metabolize the hazardous substances into the less harmful compounds. So this work is done by the microorganisms, and they can break down the organic pollutants through processes such as biodegradation or composting. And finally we get a product known as compost, which can be used as a manure for the agriculture purposes. And biological stabilization is particularly effective for organic contaminants, but it also may be used in conjugation with other stabilization methods for various complex waste streams. And also next one is we are going to see about the ion exchange process. Ion exchange process involves the removal of hazardous ions from solutions by replacing them with less harmful ions on the surface of an ion exchange resin. So the hazardous ions will be taken up by the resin, and which will be exchanged by other non-hazardous ions. This process effectively immobilizes hazardous ions and reduces their mobility in the waste stream. Ion exchange is commonly used for treating wastewater containing heavy metals, radionuclides, or other toxic ions. And next method is the adsorption. So we all know adsorption means which are being captured at the surface of some adsorbent materials. So it's a process by which hazardous materials are removed from solution by adhering to a surface of an adsorbent material. Mostly activated carbon is used as an adsorbent to remove organic pollutants, heavy metals, and other contaminants. And also this method effectively immobilizes hazardous substances, reducing the concentration in the waste stream. And next process is, as we all know, the stabilization of solidification. Already we have seen this process in detail in the previous video. Mixing the waste with additives such as cement, and then we are encapsulating, and it is being disposed it safely, and it reduces the potential of harmful, reducing the potential harm to the environment and release. So that's all about the mechanism of stabilization. Thank you for listening.